Hello, today we are doing lesson 1.7, which is representing functions as graphs. It says graph the function y equals 1/2 x with the domain 0, 2, 4, 6, and 8. So next on chapter 4, we're going to get more into using our coordinate plane. This is x and this is y. I know that because, well, first of all, that's the way graphs are. However, the letter y is longer than x, which tells me that y goes up and down, our vertical. Easy way to remember which is which. So in order to graph, we need to make a table because we don't know what the y values are. We do know what the x values are, our domain, what we're plugging in to our equation, which we have the equation right here. So I'm going to make an xy table, and I know we're plugging in a 0, a 2, a 4, 6, and 8. So in order to figure out what y is, we need to plug our x's into our equation. So if I plug in a 0, 1/2 times 0, well, half of 0 is still just 0. If I plug in a 2, 1/2 times 2, or half of 2 is 1. If I plug in a 4, half of 4 is 2. You're really just multiplying the top and the bottom if you were to make them both fractions. Then half of 6 would be 3, and then half of 8 would be 4. So we're going to go ahead and plot these points on our coordinate plane. Our x goes left to right, and our y goes up and down, vertical. So if we start with this one right here, x is 0 and y is 0. So right in the middle. And here are our numbers going this way, 1, 2, 3, 4, 5, and so on. And this way, 1, 2, 3, 4, 5. This way would be negatives, -1, -2, and then down would be negatives as well. We don't have any negative numbers, so we're going to all stay in the positive side. Then, if I go to my next point here, we have 2 and 1. X is 2, so I'm going to go over to 2, and y is up 1. Then at 4, I'm up 2, right here. Then at 6, I'm up 3. And then at 8, I'm up 1, 2, 3, 4. So we plotted the points. We're not going to draw a line through them because we only plugged in 1, 2, 3, 4, 5 numbers. Okay? This is our answer. We graphed that function. Let's take a look at another one. We're going to graph this function. They're telling us our domain, what we're plugging in to our table, are the numbers 0, 1, 2, 3, 4, and 5. We need to figure out what is y. So let's plug those numbers in here for x. If I plug in a 0, we have 10 minus 2 times 0. Order of operations always tells me to multiply first, so I'm not doing 10 minus 2. I cannot do that. We have 10 minus 2 times 0, which is 0. 10 minus 0 is 10. Then, if I do the same thing, but with a 1, 2 times 1 is 2, so we really have 10 minus 2, which is 8. I'm just erasing that so I have space. Then if I plug in a 2, 10 minus 2 times 2. Well, 2 times 2 is 4, so 10 minus 4 is going to give me 6. Now some of you may be able to figure out our pattern here. From 10, 8, 6, what's happening? We're going down by 2, which is exactly our function rule here. This one is just negative 2x plus 10. They just wrote it in a different order. This is a positive 10. So you could predict what would come next. If I subtract 2, I would get 4. Subtract 2, subtract 2. We can check to see if that works. If I plug in a 3, 2 times 3 is 6. 10 minus 6, yep, it's 4. So our pattern does work. So let's go ahead and plot these points. X goes left to right, and y are output goes up and down. So at x, when x is 0, y is up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is all the way at the top. So when x is 0, y is up to 10. When x is 1, we're up 8. At 2, we're up 6. At 3, we're up 4. You can kind of see the pattern here. At 4, we're up 2. And then at 5, we're at 0 for the y's. There's our graph. We have all 6 points plotted. Alright, next it says analyze a graph. The graph shows guitar sales in millions of dollars for a chain of music stores from the period 1999 to 2005. Identify the independent variable and the dependent variable. Describe how sales changed over the period and how you would expect sales in 2006 to compare to 2005. Well, they asked us a lot of questions there. The first whole part here, this part up top, didn't really tell us a whole lot. It's just telling us what the graph is talking about, guitar sales. Next, they want us to identify the independent and dependent variables. Independent is what we would plug in for the letter X, and our dependent variable, remember, is our Y's, what you get out. Our sales depends on how many years it's been, how many years we've been in business. So our independent X would be the number of years, and our dependent variable would be the sales. So this is Y and this is X. Then describe how sales change over the period of time. As the years go on, I'm just going to say, as years go on, what's happening to our sales? After the number of years, our sales are going up. Say the sales, a mathematical or science word we could use would be increase. If you say go up, that means the same thing. So they want to know, how would you expect sales to be in 2006 to compare to 2005? So this says years since 1999. If it's been 0 years since 1999, it's still the year 1999. Then after 1 year, it's the year 2000. Then 2 years, it's really 2001. This would be 2002, 2003, 2004, right here. 2005 would really be year 6. So they say, how will the sales in 2006, really at year 7, compare to the year 2005? So here, what would you expect to happen? Well, wouldn't we expect the sales to be like somewhere up here? So we would expect the sales to continue to increase. So you can say that we expect sales to increase in 2006. And now that it's past that year, we would probably know. So let's take a look at our next two. It says write a rule for the function represented by the graph. Identify domain and range. Well, we haven't learned how to write a rule for a graph, but we do know how to write a rule from a table. So I'm going to take these numbers and put them in a table form. Here's our x values and here's our y values. In between here, they go by ones. We can fill in the numbers. I'm going to go from x when x is 0 to begin with, and then moving to the right. So when x is 0, y is up here at 5. When x is 1, y is up here at 4. When x is 2, y is at 3. When x is 3, right here, y is at 2. And then the last dot they have on there, when x is 4, y is at 1. So we're going to write our rule. Well, you can tell from one number to the next, because our x's go by ones, remember? From one number to the next, we are just subtracting 1. So our rule, we're going to subtract 1. And then our number that's added or subtracted on the end, always look for when x is 0, we really have a positive 5. So remember how we create our equation? Our function rule is what's happening multiple times, subtract 1, subtract 1. Each time you're subtracting 1, but whatever you get you have to add 5 to. So if you want to test one out, if I plug in, let's just pick one, if I plug in a 2, negative 1 times 2 would give me negative 2, so I'd have to add 5 more to get to 3. So there's our function, negative 1x plus 5. Let's do the same thing with this other table, x, y. Be careful though, every other line is 10, so in between here we'd have 5. So 5, 10, 15, 20, 25, and these ones go by ones. So our table, when x is 0, we don't have anything there. When x is 1, we're up to 10. When x is 2, we're up to 15. At 3, right there, we're up to 20. And at 4, we're up to 25. So you can tell our pattern is adding 5 each time. So I know y equals 5x. We're adding 5 each time, really, taking our input, our x value, and multiplying it by 5. But that's not going to get us to 10. 1 times 5 is not going to get us to 10. We need 5 more. Or if we work backwards in our table, subtract 5. Looking at 0, we do need to add 5. So test a number if you're not sure. 3, if I plug in 3, 5 times 3 is 15. 15 plus 5 does give us 20. So this is our rule, y equals 5x plus 5. Last question, write a rule for the function represented by the graph, and then identify the domain and range. So just like we did before, I'm going to make an XY table. If it helps you to number the lines, go ahead and do so. Remember, this is X left to right. Y is the longer letter, goes up and down. And going this direction would be negatives. So I always start with when x is the lowest. Here at 0, we're up 1, 2, 3. So x is 0, y is at 3. X is at 1 here, y is also at 1. X is at 2, we're down 1, or negative 1. X is 3, we are down 1, 2, 3, negative 3. And then at 4, we're down a negative 5. So our pattern on this one, writing our rule to get y, we are going down 2 each time. And then looking when x is 0, we have a positive 3. So whatever you get, you really need to add 3 to. Because if I were to plug in a 0, negative 2 times 0 is 0, but we need to get 3, so we have to add 3. So our domain and range, last question here. Domain is what we plug in. We plugged in a 0, a 1, a 2, 3, 4, and 5. In our range, we got out 3, 1, negative 1, negative 3, and negative 5. So if we're given a graph, we can take that and convert it to a table and then write an equation from that. If we have an equation, we can make a table to figure out how to graph it. We didn't really learn about this one. If you want to learn, let me know. Otherwise, we've learned how to represent a function as an equation, a table, and as a graph. They all represent the same situation. All right, go ahead and grab your worksheet 1.7.